Welcome all. This is Dr. CVR Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are here to discuss about sorting techniques and its basic terminology used in sorting techniques. Sorting refers to arranging data in a particular format, either in ascending or in descending order. It specifies sorting algorithm specifies the way to arrange the data in a particular order. So sorting is arranging the data. Sorting algorithm specifies the way to arrange the data in some order. What are the advantages of sorting? So the major advantage of sorting is it helps in searching operation. Data searching can be optimized to a very high level to represent data in more readable formats. Examples for sorting techniques are some real-time examples are telephone directory and dictionary. We cannot imagine dictionary when it is not in some sorted order. We cannot find the meaning of some words or meaning of some word in a dictionary if it is not in an order. It will be a very difficult task to find the meaning of a particular word if the dictionary is not in sorted order. Sorting algorithms may require some extra space for comparison and temporary storage of few data elements. So, basing on this particular principle, the sorting algorithms can be classified into two things. One is in-place sorting and the other one is not in-place sorting. In-place sorting algorithms which do not require any extra space, for sorting the given list are known as in-place sorting algorithms. The best examples for in-place sorting are bubble sort. Not in-place sorting algorithms that requires extra space for comparison and temporary storage space are known as not in place sorting algorithms. Examples: merge sort. If a sorting algorithm, after sorting the contents, does not change the sequence of similar content in which they appear, then it is known as stable sorting. That means this is the given list and the list obtained after sorting is this one. Here we are having two elements. We are having 26 twice in the given list. If we preserve the same order in the resultant sorted list, then we can call this sorting technique as a stable sorting technique. The preservance of occurrence of the same elements, is maintained, then that is known as stable sorting. Otherwise, unstable sorting. Now we can check with an example. Here in the list we are again having the same number 26 for twice, but the occurrence of 26, the latter occurrence of 26 is placed first in the sorted list and the prior occurrence is placed next in the sorted list. Here the order of occurrence of same element is not maintained in the sorted list. So that's why the sorting technique which we use, or the sorting technique which results into this list, is known as unstable sorting. The definition for unstable sorting is if a sorting algorithm, after sorting the contents, changes the sequence of similar content in which they appear, is called as unstable sorting. Adaptive sorting algorithms. What do we mean by adaptive sorting algorithms? In a few sorting algorithms, the complexity changes based on pre-sorted input That is, pre-sorted array of input affects the running time. If the given list or else the given elements in an array are already in sorted order, then it may affect the running time, the running complexity of the sorting algorithm. In that case, we'll uh, categorize the algorithms depending on their characteristics. Suppose algorithms like quicksort is known as an adaptive sorting algorithm because the timing complexity for quicksort depends on the initial input sequence. If the input is already in sorted, then the timing complexity reaches order of n square in quicksort. If the input sequence or else if the input list is not in sorted order, then the timing complexity becomes order of log n. That means the input is already in sorted order, then it increases the timing complexity of the sorting algorithm. And if it is not in order, then the sorting algorithm may give you or may have the best timing complexity like order of n log n. Such kind of sorting techniques are known as adaptive sorting algorithms. Quicksort is a best example for that. And some adaptive algorithms are bubble sort, insertion sort. Some more adaptive sorting algorithms are bubble sort, insertion sort, etc. On the other hand, some non-adaptive algorithms are selection sort, merge sort, and heap sort. And generally, we will get questions something like arrange the list in increasing order using some algorithm, or else arrange the list in decreasing order, or non-increasing order, or non-decreasing order. Some kind of questions we may get in exams. Let us see what do you mean by increasing order or decreasing order, or non-increasing or non-decreasing. The increasing order means the successive element is greater than the previous one. If the successive element is greater than the previous element, then it is known as increasing order. Here is an example: 1, 3, 4, 6, 8, and 9. Here, take any element. Let us take 3. It is greater than the previous element. Take 8. It is greater than its previous element 6. Like that. If every element is greater than its previous element, then we say that the list is in increasing order, strictly increasing order. Coming to decreasing order, if the successive element is less than the current one, then we'll call that order is decreasing order. Examples are 9, 8, 6, 4, 3, 1. The same list which is in reverse order. Here, take some element 8. When you compare this 8 with its next element, it is greater than the next element, or else it is less than its previous element 9. So, in such a case, we'll call that order as decreasing order. Now, what is a non-increasing order? In non-increasive order, the successive element is less than or equal to its previous element in the sequence. In the previous definition, in increasing order, there is no term like equal, strictly less than or strictly greater than. But here, in non-increasing order, we are having less than or equivalent to its previous one. Then we will call that one as non-decreasing order. This order occurs when the sequence contains duplicate values. Example 9, 8, 6, 3, 3, and 1. Here, take element 6. It is less than its next element. Sorry, the successive element of 6, that is 3, is less than 6. Next, take this element. It is also less than its successive element 1. But coming to this element is equivalent to its successive element 3. So we will have duplicates in non-increasing order. But in increasing order, we don't allow duplicates. Coming to non-decreasing order, the successive element is greater than or equivalent to its previous element in the sequence. Here, in the example, let us take this one, this element. Its successive element is greater than or equivalent to. Here, it satisfies the equal to operation. It satisfies that property. So, it is a non-decreasing order. Let us take this one. Its successive element is greater than this element 3. Its successive element is 6, which is greater than this 3. So, if we are having a list like this, then we will call it as a non-decreasing order. So, whenever we are solving problems, if that problem statement or the input is having some duplicate numbers, then we have to make use of the terms like non-increasing or non-decreasing order, but not like increasing or decreasing order. If all the elements differ, then we will go with either increasing or decreasing order. So with this, I think we understood some basic terminology that are related to sorting techniques. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.